Okay, so I'd like to welcome everybody to number 128 of the Circle and Wine Writers Let's Talk series. Today's topic is the science of soil and how it influences our wine with Sunny Hodge. I'd like to extend a welcome to our members joining for the first time, but I've actually seen many people here who aren't members, so we do welcome you today. The Circle of Wine Writers was founded in 1960 in the UK. And today there's 270 plus members all around the world. So the split today is really 50-50. There's more information about the Circle on our website, and also you can make an application to join online there also. I'd now like to hand over to Meg Maker, our chairman, who will introduce our speaker, Sunny Hodge, today. Over to you, Meg.
Excellent. Thank you, Andrea. Thank you to all for joining us today. I think this is going to be a really terrific session. I've been looking forward to it for weeks, and I am really looking forward to what Sunny has to say to us. When Sunny applied to become a member of the Circle earlier this year, he was enthusiastically welcomed, and he submitted as writing examples the first two chapters of his book, The Cynic's Guide to Wine, and I was smitten. The book is a clear-eyed take on wine and wine science, and I think it's urgently necessary. In addition to being a wine writer, lecturer, and commentator with a very active social media presence, so we can follow along on Instagram and elsewhere, Sunny is also the founder of two award-winning London wine bars, Diogenes the Dog and Aspen and Merceau. He judges for the IWSC Awards, and he also mentors others through the Drinclusive Diversity Initiative. He has a degree in mechanical engineering from University College London, and so that means that he turns a keen scientist's eye toward all things wine. So please join me in welcoming Sunny. Please do drop your questions in the chat, and we'll be taking them as we go along. Thank you.
Cool. Hey, everyone. Thank you so much for joining. Thank you so much for that wonderful intro. I'm going to run a presentation which should help us understand some of those mechanisms in regards to how soil influences your vine, and then how that can or may not influence your wine. Having worked in wine for quite some time, like a lot of you guys, there are lots of things that we assume in wine where maybe those links aren't formed. And most of those assumptions come down to terroir, to soil, and how that interplay works. So this presentation, the whole aim is to help us better understand some of the basic soil mechanisms, how your vine reacts to different soil types, and then you guys can just make your own decisions on how you feel that might affect your vine or not. And at the Q&A at the end, we can hash out any final questions that you have. Throughout the session, I will ask questions and I'll throw it over to Meg to open it up to you guys. And it's more just to check that we're understanding as we go, because there are some really complex chemical and scientific bits that we're going to touch on in relation to soil. So I will crack on with sharing my screen. Awesome. And I'm going to try and draw as we go. Meg, can you see all that okay? Is that coming up nicely?
Looks great. Looks great.
Awesome.
Thank you.
Okay, perfect. So what we're going to cover in this session is addressing what are minerals. It's a term we use quite a bit in wine, but mean many different things. How vines can get at soil minerals. We're going to look at 5 case studies on different soil types. And we're going to touch on how farming interacts with soil and how that may or may not influence your final wine. And we're talking about the flavor of your wine and also how that affects your vine directly. We'll talk about what really matters in soil, and then we'll do a Q&A at the end. So I'm going to ask the group, Meg, this is one of my questions. What are minerals? Can anyone's welcome to write in the chat, like, what is a mineral in relation to soil? Awesome. So Patricia's mentioned that you can taste some minerals, but minerality can't be tasted. So who can tell me or take a hazard at what are minerals in our soil? Neil, what are the two kinds?
Neil, do you want to unmute?
Yeah, there's geologic and there's nutritional minerals. The nutritional ones are the ones that find their way into the vine somehow. The geologic ones are the ones that people think find their way into the vine sometime, but they don't really.
Yeah, absolutely. So minerals, thank you, Neil. Thank you so much for that. So minerals come in various forms, but simplistically, if we want to sort of have a catch-all definition, minerals are made up of organized and symmetrical arrangements of ions bonded together. And an ion, so Winnie's mentioned their descriptors for minerality, i.e. wet pebble. So I think with Winnie's description, I would say, yes, this is how we use it linguistically as like an adjective to describe aromas potentially. But in the scientific sense, minerals are made up of organized and symmetrical arrangements of ions bonded together. An ion is simply a charged element, like a charged particle. So the external, so what I'm going to do, I'm going to draw as we go. So if this is a negative ion and this is a positive ion, then that will attract a negative and that will attract a positive, and that will continue to grow into a crystalline structure. So that crystalline structure made up of ions bonded together is your mineral. This mineral will tend to have a negative charge. So this is what we would refer to as a mineral in the soil. It's just made up of different ions that have grown and formed a crystalline structure. I'm going to try and go to my next slide. Awesome. As they grow larger, they can then bind onto other minerals. And in some cases, if they're under the soil, the pressure of the soil above will compress those minerals to form rocks. So if you think about like the hierarchy of size, you have an ion, which is just a charged particle. When that ion grows magnetically by negative and positive particles, allowing it to grow, then you've got your mineral. And then if you have lots of different minerals that are compressed together under soil, you then have a rock. So your rock is essentially made up of loads of different minerals that have been compressed over pressure and long periods of time. So your rocks, very similar to your minerals, will have a net negative charge. And understanding the difference between minerals, rocks, and those magnetic attractions really help us understand how your soils and the soil structure interacts with vines and other plants. And I'm going to try and get rid of all of that. Super. We touched on this a little bit earlier. Do minerals have flavor? This is another question in the chat. Can we taste these minerals? Fred, this is like a super accurate description of minerals. Yeah. So ions that then go on to form crystalline structures, and those crystalline structures are fused together by pressure and heat over a period of time, which makes a rock. So yeah, spot on, Fred. Who can answer in the chat if we can taste these minerals? I know, was it Winnie, I think, addressed it before, whether we can taste the minerals. You can't taste them, no taste, no aroma. Neil says no. Absolutely. So, but there is one mineral that we can taste. Can anyone name the family of minerals that we can taste? Salt. Amazing. Stephen smashed it. So, Claire, well done. Thank you. So, most minerals we can't taste, and the only mineral that we can taste are halide minerals, the family of salts, and specifically it's NaCl that we can taste. So the exception is halide minerals. So salt is the one mineral we can taste, all the other minerals we can't taste. And within our understanding of minerals and particle attraction, we should also discuss the mineral hierarchy. So we mentioned before that there's a negative and positive attraction that helps our ions form crystalline structures. When we have a rock, so let's say that this is a rock underneath the soil, and it's surrounded by a negative charge, and then going through, we have soil water, and our soil water will be made up of lots of positive, tiny little cations. Now, a cation or a cation is simply another name for a positively charged ion. A positively charged ion that has a benefit to the vine is what we call a nutrient. So if you think about it, our rocks have this net negative charge, and our soil water has loads of tiny positively charged ions that some of which could have a benefit to our vines. The stronger the charge of our rock, or the stronger the charge of our cations, will mean that they're more likely to get attracted to one another. Also, the closer the magnets are, those cations and rocks, or cations and rocks, the stronger that charge, that pulling force will be. So the size of the particle makes a huge difference. For example, if you have two magnets, and excuse my drawings, but this is negative and positive, and this is positive and negatively charged, the distance here will affect the strength of that magnetic pull. If you have a big particle and another big particle, your centers of gravity, or your center of mass, determines how far away those particles are. But if you have a small particle, then that, in terms of the center of mass, is closer than a larger particle. And this is essentially how charges work. They're based on the probabilities of the centers of your cations or anions, your negatively charged particles. So the two things that determine the strength of that charge are, number one, how positively or negatively charged those particles are. And number two is the size of the particle, which determines how close or far apart those particles are. Now, this is great, but what's that got to do with our vine And how's this got anything to do with vine nutrition? And how do those vines actually access those nutrients? Well, we're going to draw up a rock. Where are we? Oh, I'm going to draw up a rock over here, which we know is surrounded by a negative charge. And then we've got our positive cations that are in the soil water that eventually will end up sticking onto that rock. Now, our vine roots, let's say that this is a vine root, have the ability, which is the beauty of nature, to pump out hydrogen cations. Now, hydrogen cations are the smallest ions you can get. They're just a single proton in size. Vines metabolize them from water. So if you think of water is H2O, when vines take up their H2O, they release the oxygen out into the atmosphere, and they have a free hydrogen ion to do with whatever they want. And these hydrogen ions actually form the top of the mineral hierarchy, the mineral charge hierarchy. They're the most highly charged particle purely because they're so small. So our vines can actually release these hydrogen cations, these single protons, which are super highly charged. They smash onto your rock and then release lots of free, weaker cations. And those free, weaker cations are simply nutrients. And then our vine can access them, because previously those nutrients will be stuck onto the rock. And now they're free in the soil water to be taken up by those vine roots. So it's a really clever system that all plants utilize. It's how plants get nutrients, by pumping out hydrogen ions, which are heavily charged, to displace nutrients from rocks that have got stuck there from the soil water. It's a lot to take in. Does anyone have any questions on that so far? Because this understanding of how all plants get nutrients from rocks in the soil will help us understand what the different rocks do. Has anyone questions so far before I move on?
I'm mostly just seeing comments, Sunny.
Okay, cool. So
and there's a big focus on the minerality, the illusion of minerality, and the discussion about what that actually is from. So I'm sure that people will have questions about that at the end as well. At the end.
Okay, cool. And I guess within this chat, the difference between minerality in wine, or the smell of minerality, is not what I'm talking about here. I'm talking about physical minerals in the soil, because minerality in wine is just an adjective that we apply to a set of smells. And now that we know that minerals, apart from salt, don't have a flavor, I guess it sort of makes us rethink of whether we should be using the term minerality in wine if we know that minerals don't have a flavor. Within the English language, our method of describing smells is just by naming other things that smell like things. So this wine smells like plums, or forest floor, or pencil shavings. But in this case, I think using minerality to describe a set of smells may not be super accurate, because most minerals, apart from salt, don't have flavor. But I think that's more of a language discussion than a science discussion. I'm going to crack on. So I've got over here a little illustration that was going to go in the book, but then the publisher wasn't too keen on them. And I'm going to cross out my previous work. So here we have an illustration of this process, which is called cation exchange. So if you see at the bottom of the screen here, you have your rock. These little yellow guys are your positively charged cations. And these cations could be like magnesium cations, calcium. They're like little ionically charged positive particles. So they're the same sort of particles that you'll find on the periodic table. Then you have your vines with your roots that are chucking down little hydrogen bombs that are then displacing all of those positively charged particles back into the soil water so the vine can now access it. In addition to this, and something that we'll touch on later, we have mycelium assistance. So like mycelium are the little beardy rooted structures that form their fungal networks that form underneath the ground in the soils. And they also help vines access nutrients. They could do that by accessing quite tricky nutrients to get hold of, maybe ones like iron. So iron, for example, is highly reactive. And because it's highly reactive, it'll oxidize and not be available for vines easily. So mycelium will be able to sort of chisel them away, give them to vines in exchange for carbon, because most mycelial networks don't photosynthesize, so they're unable to produce carbon. So mycelium in this whole scenario is very much our friend and do symbiotically assist vines in getting nutrients that they won't normally be able to get hold of. And in addition to that, they increase the surface area of the roots to access water and get into places that they wouldn't normally be able to get into. So mycelium is very much our friend here. And I'm going to keep going. So let's get on to our first case study. We're going to talk about champagne. Oh, sorry, I am having a little bit of difficulty with drawing on the screen and moving through those slides. Awesome. So we're going to talk about champagne. What soils, and you can put this in the chat, are synonymous with the soils of Champagne? Beautiful. So here's a little thank you, Claire, awesome, Linda, amazing, Chalk, Patricia, awesome. And I would say that chalk would be a type of limestone. So yeah, chalk and limestone, all brilliant responses. Here, I've got a little excerpt from the Michelin Guide. We can comment on that a little bit later, that essentially uses chalk as an explanation for the taste of champagne. And then, so what soils are champagne from? Chalk soils. What is a chalk? It is a type of limestone, and limestones are simply sedimentary rocks. So I find with the rocks, the easiest way to tell them all apart is to categorize them. I know that when I started off in wine, learning about clays and chalks and granite, like none of it made any sense to me, and I had no way of categorizing them. But broadly, sedimentary rocks are rocks that are made up of tiny little sediments, which is in the name. Limestone is a type of sedimentary rock, and chalk is a type of limestone. So what's a sedimentary rock? They're made up of bonded sediments. Limestones in particular are made up of dissolved components that then solidify. And if they have high proportions of calcite, then that makes them a limestone. So limestones technically are sedimentary rocks with high proportions of calcite, which is formed from calcium, and which is why a lot of the time chalks are made from dead animals that have been fossilized over time. So chalk is made up of plankton skeletons, which is where the calcium comes from. It comes physically from animal skeletons because it doesn't exist widely in nature in high concentrations outside of living things. So what properties do limestones have? Well, here are three little things that I think most of us will already know. So they're granular, which means that water can get inside and they can retain water. Once filled and saturated with water, they're free draining. And they tend, from a color perspective, to range from bright whites to gray. So in the whole realm of looking at rock colors, limestones tend to be on the lighter side. Now, when you're looking at them, the top two, so granular and retaining water, that's great because they form like little batteries, little water packs, and in dry periods of time, your vines have a little battery pack full of water that they can access. The fact that when they're filled, they're free draining is brilliant because it means that your soils don't get clogged or waterlogged. And color, in some respects, could be hugely positive. So the lighter the color of your soils, the more photosynthetic light is being shone back onto your vines. And depending on where you are in the world, that might be a hugely positive thing. So lighter colored soils will tend to reflect more light back into your canopy. Hence, your vines are photosynthesizing more. So you would assume that the more limestone concentration you have in your soils and the lighter that limestone is, the more photosynthesizing your vines will have an opportunity to do. Those top three things, quite a few rocks can do. I wouldn't say that they were like purely just the limestone thing. There are lots of other rocks that are granular and can retain water. There are lots of other rocks that are free draining. And okay, limestones tend to be lighter, but there are other lighter rocks that exist, like travertines and things like that are also light in color. But what can limestones do that other rocks can't? So if anyone can write in the chat, like the limestone's superpower that it can do that no other rock is able to do.
Come on, people, we know this. Drop it in the chat. Anybody? Well, they changed the pH.
Absolutely, Meg, thank you. Who was it that wrote? Stephen provides lots of copy for meaningless back labels. I love that. Absolutely, Meg, spot on. So they change the acidity of your soils. So the more limestone you'll have, the higher a pH you'll have, which means that your soils will tend to alkalinity. Here we have, so pH, I think pH is your measure of acidity, and can you still see my screen that I'm sharing?
Yes.
Yeah,
we can
okay.
see it.
So pH is your measure of acidity, and put simply, your acidity is a concentration of hydrogen ions. So the more concentrated a set of hydrogen ions you have, the higher in acidity. The less concentration of hydrogen ions you have, the more alkaline it is. And I'm going to try and step forwards. Ooh. I'm just going to try and share again. Sorry that I pushed something, and I'm going to reshare this screen.
We can see your screen.
You can see it.
Yeah,
I'm
we can
unable
see
to.
it. Is it possible that at the top, Zoom gives you an option to choose between, choose between seeing a screen and seeing the presenter. So
Yeah.
now we can't see your screen. Now your screen is stopped sharing.
No, you can't. Let me do that again. All
Okay.
right. All right. Can you see my screen now?
Yeah.
Yeah.
Yes.
Okay,
Yes,
cool.
it's starting. Yep.
I'm gonna. Awesome. So the way that that limestone changes the alkalinity, changes the acidity of our soils is so calcareous rocks, which means rocks with huge amounts of calcium carbonate. They bond with the free hydrogen ions in the soil, which then means that the concentration of hydrogen ions in the soil is far lower than it was before. So it reduces the acidity whilst increasing the alkalinity. So the more limestone you have, the higher alkalinity you'll have in your soils. And there's no other rock that can quite do that like limestones can. And I think that's really useful in knowing, because now we can talk about limestones. We know what three properties they have. And in addition, their superpower is by changing the acidity of your soils. Does soil acidity make a difference? Because now what we've done is we've understood that limestones change the acidity composition of the soils, but how does that affect your vines? And does that affect your wine? So looking at studies so far, there's very little correlation in terms of soil acidity changing consistently the flavor profile of a wine. But we do know that soil acidity changes the nutrient availability of your soils. So some nutrients are more soluble in different acidities. So depending on the specific acidity of your soil, that will determine what of those cations, those cation nutrients, are available and readily available and which ones are not. So let's say that you have a mineral deficiency in your soils, then changing the acidity of your soils can fix or worsen that, depending on your original setup. All right, we're going to move on to clay. Patricia, you're absolutely correct there in terms of pH and acidity not being exactly the same, but I think for the purposes of this session, I think it helps just us get our heads around how acidity works and how, in that instance, limestone makes a huge difference to the acidity of soils. We're going to talk clay. So who can tell me in the chat what type of rock clay is?
Thundering silence.
So there may be clays made like from volcanic rocks, compressed mud. Clay, I'm going to give it to you, is also a sedimentary rock, but it references the particle size. So we understood from the previous little limestone case study that limestone is a sedimentary rock. So it's made up of loads of particles compressed over a period of time and heat to make a rock. Clays are the smallest particle-sized sedimentary rock. The properties that clays have are they have very little water retention, so they don't let a lot of water through, and because of that, wet clays are really watertight. They can cause huge damage to your vineyards by waterlogging, like your vines, and really not storing much water, which can be problematic at times. But if we were to talk about clay's USP, like the thing that it can do that no other rock can do, can anyone hazard a guess as to what clay's superpower might be? All right, I'm gonna jump in there. So because clay is made up, and Patricia, yeah, bang on. So clay particles are tiny. Because clay is so small in its particle size, it actually has like a huge surface area. So as we know, clay can be formed into like many different shapes, and its tiny particles means that soil water can actually get inside different parts of it. And on a microscopic scale, the surface area of clay is like humongous. And if you go back to our cation exchange and think of the magnets and the amount of cations that can get stuck onto the surface of a rock, with a clay, we're talking exponentially larger surface areas than traditional rocks that just have like a set shape like a limestone. Because it's moldable and because it has a microscopically huge surface area, clays have some of the highest cation exchange surface areas, which means that they have a huge, what's referred to as a cation exchange capacity, which is just a measure of fertility. Because if clays can attract the most amount of cations, then that means that clays will have more nutrient cations attached to them, which therefore increases the fertility of your soils. So that would be clay's USP. If you have lots of clay in your vineyards, you would expect them to be very fertile. And if you have lots of limestone in your vineyards, then you'll expect those soils to have a higher alkalinity. And then we've got some little written commentary, which I've included in the presentation because I think the things that we're speaking about so far, especially if we're talking about soil fertility in regards to clay, it doesn't actually change directly the flavor of your wine. And it does very much depend on where you are. So if you are in need of more fertility based on your specific microclimate, then clays will help you. But if you have enough, depending on where you are, then clays, maybe it's problematic. Maybe you've got too much vigor in your vines, for example. So I would say that the composition of your soils, be it clay or limestone or whatever it may be, is only a negative or a positive thing based on where specifically you are. But at least now we can understand what major things they go on to changing. All right, Neil, I know you spoke about volcanic rocks before. So what are volcanic rocks? They're igneous rocks. So igneous rocks are just formed they're essentially melted rocks underneath the Earth's crust that come up to the surface quite quickly. So if you think of your core of the Earth being really hot and that's just full of magma, and then let's say that there's like a volcano which allows magma out into the surface of the Earth, which is significantly cooler than the core of the Earth, then you've got molten rock that very, very quickly solidifies. This is essentially a volcanic rock. Volcanic rocks tend to be really, really porous. So they have loads of like little holes in them that you can see. And that porosity is caused by the lava rising to the surface really, really quickly, and the pressure on that molten magma releasing. So I think the easiest way to picture this is if you've ever seen like those ocean documentaries, and you see like the whales swimming around, and then you see like a little bubble on the bottom of the ocean that's teeny, teeny, tiny. And then as the bubble comes up to the surface, it gets larger and larger and larger. The reason that happens is the deeper down you are in the sea or in the earth, you have the weight of the bits above you pushing you down. So that little bubble, be it in your molten lava or in the ocean, when it has loads of pressure, the deeper down it is, it's super, super small. And then as that pressure releases and gives you a little bit more wiggle space, that bubble will get larger and larger because it's allowed to expand because the pressure is reducing. Hence, your tiny little bubble near the Earth's center will get bigger as the pressure releases. So those igneous rocks and those volcanic rocks will tend to have loads of these little air bubbles that are expanded air bubbles that have formed because the lava isn't under so much pressure anymore because it's on the Earth's surface. So I think there are many types of different volcanic soils. This is the one thing that I would say they would all have in common, because if you think about melted magma, they could be made up of any composition that's found in the Earth's core. So they'll all solidify in different forms and be made of different compositions, but they will all have that one thing in common, which is they're very porous. How does that porosity go on to affect your vine? Well, that porosity allows water retention. The porosity also means more surface area because there's like an oak barrel, you've got loads of little niches and pores that increase your surface area, hence increase your cation exchange capacity, and therefore increase your soil fertility. And then finally, those little holes are living areas for microbes. So microbes positively affect your soil's ability to break down components and turn them into smaller nutrients and cations that vines can take up. Vines don't have the ability to take up huge rocks or bigger particles, so microbes being around do facilitate the breaking down into smaller cations that your vines can take up. So I would say volcanic soils, those are the three biggies that would be their USPs, but largely based on their structure and them being porous. And I've got a little excerpt from Wine Enthusiast, which, again, I love Wine Enthusiast, but I wouldn't necessarily, I don't think I'd be brave enough to put those soil mechanisms and relate them to specific flavors in wine. Case study 4, potassium cations. So as we touched on before, a cation is just a positively charged particle. We find those positively charged cations in the soil largely from decaying matter above the soil. So when rocks above the soil are breaking down, when trees or organic matters are breaking down, that's how all of your cations will get back into the soil. A lot of that is also broken down in the topsoil, but the majority of your cations entering that soil water will come from stuff that's above the ground. Now, potassium cations are present in the fruits. So it's one of the few cations that if you have more in your soil, you'll find them all the way in your grape. It's actually the most abundant cation in plant tissues and in grapes as a single cation. Why are they the most abundant cation in grapes? Well, vines use those potassium ions for single-use jobs. One of those single-use jobs could be like the opening and closing of leaf stomata, which will help them regulate water and evaporation. And they need to be stored somewhere so that the vine can use them when they need to. How does that go on to change our wine? So if we've seen those little wine crystals or tartaric acid crystals, they need little landing pads to solidify. So if you have lots of potassium cations or calcium cations in your wine, you've got more little landing pads for that tartaric acid to solidify on. Hence, you'll end up with more little wine crystals in your wine. Most producers will cold stabilize their wines. So that'll be cooling your wine down, making those little crystals form, and then filtering them away because they're seen as a form of instability in wine, which directly would reduce the total acidity of your wine. So if you have lots of potassium in your soils, they'll end up in your wine. And then if you do cold stabilize, that'll directly mean you'll lose a lot of that original acidity that had solidified in tartrate crystals in your wine. So that will directly affect your manufacturing method for your wine, will then go on to reducing the acidity of your wine, which then could shift the color of your wine from purple to blue and change the overall stability of your wine. So where are parts of the world that have high potassium concentrations? A lot of vineyards in Australia have been tested and have proven to have high potassium concentrations. It's a large reason why people do acidify in Australia. Yes, the heat as well, the heat metabolizing malic and citric acid means that your grapes will have less acid. But on top of that, if you have high potassium soils, then another reason to have to acidify. All right. And then finally,
Sunny, can I just jump in here? I just want to say you have 10 minutes left.
Oh, cool.
And there are a couple of other questions and some general discussion, I think, maybe for the end. So just want to give you a little time check.
I appreciate that. I'm gonna blitz through this. Thank you, Meg, for that. There's a lot of detail in this. So now we're going to talk about farming. So if we look at the Champagne as our first case study, we found that the soils that were associated with Champagne were chalk, and chalk soils will decrease the acidity of your soils. If we're conventionally farming, let's say that we're using ammonia or nitrogen fertilizers, that will release hydrogen ions back into your soil, which will essentially acidify your soils. So the more of those nitrogen ammonium fertilizers that you're using, the higher the acidity of your soil will be. So if we're saying hypothetically that champagnes are brilliant because of their chalk soils, then the chalk soil USP was reducing acidity. But if you are conventionally farming, then you're picking them right back up again. With your clay soils, we said the USP was increasing the fertility off those soils. But equally, if you're conventionally farming, you'll be adding nutrients into your soil in addition to that. With volcanic soils, again, we're talking about fertility. And a lot of the time, if you are adding that fertility into the ground, the USP of your soil doesn't matter as much as maybe you spoke about. Potassium, again, if you're using NPK, you're adding more potassium into your soils, so that would make less of an impact, less of a difference to your final wine. And the final wine that I wanted to discuss was a wine that we used to bring in from China, which is organically farmed. And here I would say with farming regeneratively or biodynamically or organically, if you're not putting those cations back into the soil, then you're left with a wine that does represent how the soil has influenced it. I'm going to speed this up because I know we don't have too much time, but the soil does have mechanisms of its own to regenerate itself. So one of those is bacterial assistance. So soil bacteria helping with nitrogen release. The other one we touched on before was mycorrhizal symbiosis. So that's those little worldwide web fungal networks under the soil assisting in your vines and plants getting more nutrients that were quite hard to access. And then natural humus, so decaying organic matter, which actually has a higher cation exchange capacity than clay would do, for example. So even though clay's USP was to have a really high cation exchange capacity, hence high fertility, natural humus will have more than that. And it's breeding grounds for bacteria, which will also help give more nutrients to your soil. So does geology matter? Well, we've discussed color, how that can have an effect on your vines' photosynthetic light getting to them. We've discussed how it can change your soil acidity, but depending on how you're farming, that will also affect your soil acidity. It'll impact fertility, but again, depending on how you're farming will affect your vines. We've discovered that humus, and this is like a little illustration of rotting organic matter, makes a real difference. And equally, your microbial life in the soils will have make a huge difference as well. A little saying by Professor Gerard Seguin, who did many studies on soil impacting wine, and his take home from the study was excellent wines can be produced on acidic, basic, and neutral soils. They can be produced on soils with well-balanced chemistry and on those with nutrient deficiencies as well. So a sort of, I guess, catch-all that saying that maybe soil doesn't have so much direct effect on our wine as we often say that it may do. What does make a difference is water availability at crucial stages of vine development. The texture and porosity of your soils will aid root growth and the root's abilities to do that cation exchange process. The more compact your soils, the less available water there is to facilitate the movement of cations. And the drainage properties of the soil will also, for the same reasons, make a huge difference. I think I managed to smash it out, Meg.
Fantastic. Well done, Sunny. Thank you so much.
Thank you for that. I know some very technical, geeky soil bits, and I know that the science bits aren't always the reason that we got into wine in the first place.
Well, I think that it's just a fantastic presentation, and I invite everybody to follow Sunny on Instagram if you're on at Sunny Hodge Wine. I also dropped the name of the book and how it's available into the chat as well.
Thank you.
And so I think that a lot of the comments and questions that are coming through had to do with how we talk about this and how much evidence we have to make claims about the finished product and its organoleptic properties based on the soils. And I think you've showed us some examples of this in your slides, but I'd just like your own, just express your personal opinion, if you would,
Yeah.
about how far out onto that thin ice one should tread.
So I feel that we're forging a new space for articulating our way around wine. So what I feel that we've extrapolated quite a bit in wine, because wine has been a premium product for such a long time. And we sold phenomenally good wine at a premium rate pre-germ theory. So even before we understood that it was a living yeast that fermented wine, we were selling very pricey Chateauneuf de Papes and champagnes and all sorts of things. So for a long time, we've built a language around wine that predates scientific understanding of how it works. And I feel that now we're at a time where we do understand a lot about those processes, but our language is still very similar to how it was thought of before. Our language around terroir, our language around soil. Some of those are hugely emotive and do help us selling wine. Like from a marketing perspective, it's very difficult to sell wine without building those stories and building that romance around why specific vineyards have specific soil types. And in a way, soil is a fingerprint for a vineyard that can't be duplicated. So, and because of that, as a brand, it means that no one can really copy what you do. And initially, that fingerprint, that brand fingerprint saying that this is my wine and no one else can do it, means that this is what makes your wine so special. When you look at the science, it does debunk a lot of that, and it shows us that not all of that is completely accurate. And in terms of how we should speak about wine later on down the line, I don't think I'm the best person to talk to, because I don't know what that looks like. But equally, I think it's important that if we are saying something, we shouldn't believe it's true. I mean, we should arm ourselves with the tools to understand what is accurate and what is not accurate. Because I feel that beforehand, maybe we were saying things because we heard other people say them or we studied them at WSET or whatever it may be. But if that's not completely accurate, do we not want to know if that's not accurate? And then at least you have the choice to sort of spin that in a marketing sense and write that on the back of the bottle. So in terms of what we should be saying, I step away. I don't think I'm well positioned to tell anyone what they should be saying, but I think it's important that we know how things work.
That was really beautifully said. Thank you for that. Unfortunately, we're at time. There were many other very thoughtful comments and questions in the chat, and I'm not sure we're going to be able to take them all. Andrea, is there a way to save the chat and maybe send it to Sunny in case people want to strike up a
Yeah,
conversation?
absolutely. I can send the chat to Sunny and then we can take it from there.
That's
Okay.
great. And I just wanted to thank everybody for participating. It's a much more participatory forum than we normally do, and there was a lot of plates spinning, so I'm sorry if I wasn't able to get to your comments in the chat. But Sunny, thank you so much. It was really, really a fantastic presentation. And once again, just thank you.
Thank you for having me. Thank you, Meg. Thank you, Andrea.